This is Mr. Beck Does Your Homework, AP Physics, Homework 5.3, Question 13. Find the escape speed for a rocket leaving the moon. The acceleration of gravity on the moon is that much times that on Earth, and the moon's radius is that much times the radius of the Earth. So I know that the radius of the Earth is, from a previous problem, 6.37 times 10 to the 6th meters. I know that the mass of the Earth is, from a previous problem, 5.98 times 10 to the 24th kilograms. And from each one of these, you can multiply those, this one by 0.166, this one times 0.273, and get yourself the radius and the mass of the moon. But what about this escape speed? Well, what I know is that on the surface of the moon, it's going to have a certain amount of potential energy. When it gets out to infinity, it's going to have 0. So really, what I need to do is give it enough potential energy kinetic energy, so the kinetic energy is equal to the amount of potential energy it would have had here, which is negative, so I pretty much need a PE equals KE sort of calculation. So what I've got is my universal potential energy is going to be universal gravitation times the mass of the moon times the mass of the object divided by the radius of the moon is going to be how much potential energy it has on the surface of the moon. And that has to equal the kinetic energy, which is going to be 1/2 mv squared. The mass of the object is going to go away. So I can get my escape velocity is going to be the square root of twice g times the mass of the moon divided by the radius of the moon. So this is our radius of the moon, and that will give me my speed, or escape speed, from the moon. And once again, this says answer in units of kilometers per second. So whatever your velocity is here, you better take that, which is in meters per second, and divide it by 1,000 to give yourself kilometers per second.